Greetings, grade 8s. Welcome to this Worksheet Cloud, grade 8 maths lesson where we delve into Pythagoras' theorem. I'm Mr. T, your maths teacher for today. If you're confused about the lighting or it looks a little different from usual, this is the first time I'm filming in the evening. So apologies if the lighting looks a bit different, but it's still me. At Worksheet Cloud, we're all about having fun while we learn, which is why we've introduced the Rewards Hub, where you can earn rewards while you learn. Basically, you get a reward for doing what's good for you. Tough to be you guys today, but that's pretty cool. You can earn rewards like no more hot chocolate, fresh merchandise from Worksheet Cloud, or possibly even get a chance to win that PlayStation 5, which would be pretty cool. But let's get to today's maths. Pythagoras. Okay, let's begin again. I made a mistake in my previous recording of this lesson and let's try it again. So Pythagoras. My goals for today: understand how to use Pythagoras' theorem to find the missing side of a right-angled triangle. That is my only goal for this lesson, and I hope that by the end of it, you guys will be comfortable with how to do that. It is redundant for me to say a right-angled triangle because Pythagoras' theorem only works on right-angled triangles, but I put it in as a reminder. Prior knowledge: you should be comfortable with using squares and square roots. I know it's still maybe a little bit new for you at this stage, but it is kind of important for the work that we're going to be calculating today. Also, you should be able to change the subject of the formula. Maybe that's a little bit of a fancy way of saying it. I think probably most of you, when we see what we're doing, will be comfortable doing that, even if you don't know that you're changing the subject of the formula. You've been doing it probably most of your school career. You just didn't know that that's what you were doing. Okay, so Pythagoras. Well, he did some other things too. He had some other theories and to do with religion and other things. He was a philosopher, but all I really know about him is his theory of, or his Pythagoras' theorem, which is one of his maths things. He did have a couple of other maths things as well, but this one is very well used and comes up frequently in high school. And actually, it's one of the few things I learned from maths that I probably use in everyday life, believe it or not. So who was he? He was a Greek philosopher. He lived around 500 BC. So I think he was born 570 BC and he died in 495 BC. And if that confuses you, it probably confuses most people. He was born in 570 BC and he died in 495 because they were counting down the years to the birth of Jesus with BC. We should probably say BCE, which is before the Common Era, and CE, which is the Common Era. But it's a long time ago. And I don't know, it doesn't look very exciting, but I quite like his theorem. So I said there, in a right-angled triangle, unnecessarily, but I'm going to say it again, in a right-angled triangle. And that's because it only works in right-angled triangles. So you can't apply it to an equilateral triangle. You can't apply it to a scalene triangle unless your isosceles triangle is also a right-angled isosceles triangle. You can't. But in words, it sounds a bit like I don't know, you say the words and then you go, huh? What does that mean? Hopefully once we get to the pictures, I'll be able to show you what it means. And you'll be comfortable with it. But the square of the length of the hypotenuse is the proper word for the long side of a right-angled triangle, which will always be the side opposite the 90 degrees, is equal to the sum of the squares of the other two sides. Probably best that I bring up a picture. What that means, if we ignore the squares for now, is that the length of this side squared is equal to the length of this side squared plus the length of this side squared. So actually what Pythagoras had done was he drew a square over here and he worked out its area. And then he drew a square over there and worked out its area, and a square over there and worked out its area. And he discovered that no matter what right-angled triangle he drew, the area of this square was always equal to the sum of the areas of those. So when you added those two areas together, any right-angled triangle, it works. So actually this is pretty cool. So for example, if this side was 3, so 3 squared would make this 3 by 3, which is 9. So this area would be 9 squared, no, 9 units or 9 centimeters squared. Let's say this one was 4, so this would be 4 and 4, which would make it 4 times 4 is 16. So 9 plus 16 is 25. And this then would be 5, which is 5 by 5. So 5 squared is 25, which is then the same as those two together. It's pretty cool. Actually, it works not just with squares, it works with semicircles, and I think there are a couple other shapes that you can use as well. Although you won't really do this kind of stuff in maths, it is quite fun. And if you've got some spare time, you can Google some stuff or check it out on YouTube. It actually works with volume as well. So it doesn't matter how high you make it, but as long as each of them is the same high. So let's say we made this into, I suppose, a tray of water that was closed so it couldn't leak, and this into a tray of water exactly the same height, and this into the tray, and then we, I don't know, put a nail through the middle so we could turn it and connected the squares with pipes. That sounds very complicated. But if we turn the C squared to the top, these two squares would fill absolutely completely to the top with water, and there'd be not a drop left in here. And if we then turned this to the bottom, those two would empty, and this one would be filled exactly to the top, which I think is pretty cool. Maybe that's just nerdy maths teacher speak, but I like it. All right. Again, we're looking at words, and it doesn't really make a lot of sense without a picture. But once you've squared the value of the required side, you take the square root to get its actual length. It'll make a lot more sense once we get a couple of examples going. And finally, if you need a side that is not the hypotenuse, then you just change the subject of the formula, which is why I said that's important. All right, let's jump across to the whiteboard so we can look at some examples. All right, I'm going to start over here. First of all, understanding what Pythagoras was meaning with his squares and all that nonsense that he was busy with. Okay, so let's, for example, say that this side was A centimeters long, this one was B centimeters long, and this one was C centimeters long. What Pythagoras' theorem says that if we take the square of A and we add it to the square of B, then we will get the square of C. Well, let's put in some practical numbers then. So let's say we chose to make this side 3 centimeters, this side 4 centimeters, and your teachers wanted to know what was that side. All right, they might put X and say, find X. And then some smart kid on an exam paper will say, here it is. All right, which won't get you any marks because it's been done before and it's not funny anymore. All right, but yeah, if we're looking for that side. Okay, so then we would say, okay, well, we go 3 squared because that was what A was. Then we're going to add B was 4 squared, and we'd say that that is equal to C squared. So then breaking that down as numbers or making it into numbers, 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16, and that will equal to C squared. However, I'm not looking to find out what the length of this side squared is. I want to find out what that length is. So the opposite of a square is a square root. So we would then take, that's a terrible square root, we would then take the square root of C squared, which would then be C. So just to break away quickly and run that through with you, Let's say, for example, we were looking at 2 squared is equal to 4, because it means 2 times 2. So that then, if I took the root of 4, I'm asking what multiplied by itself would give me 4. So 2 times 2 would give me 4. So my answer is 2. So in other words, if I said 2 squared, which is 4, and I take the root of 2 squared, then the square and the square root cancel each other out, and what I'm left with then is 2, which is kind of what I had in the first place. All right, so I'm taking the square root of c squared to get c. But as I hope you know, when you are doing equations, if you are going to keep it equal, you have to do the same thing to the left and the right. All right, so maybe I should just say that 9 plus 16 is 25. All right, so what you do to the left, you do to the right. Actually, let me quickly make this 25 up there. So I'm doing it on the same line. All right, I'm going to take the root of 25. So I'm asking what multiplied by itself is 25, and the answer is 5. So C is equal to 5, which means that on this diagram, this side is 5 centimeters long, which is pretty cool. But unfortunately, most of the time, or fortunately, most of the time, when you're doing maths, there are very few numbers that end up as integers when you're looking at Pythagoras. In fact, there are scantily few. I'm going to quickly jump back to the slides and take a quick look at those. All right. They are specifically called Pythagoras or Pythagorean triples. So most of the time, your lengths will end up as messy numbers, and by that I mean not integers. They'll end up as like, I don't know, 5 comma da 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 da, or 8 comma da 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 da. But there are a couple that end up nicely, and they come up quite often in high school maths. So I'll mention them, although it's not critical that you do know them. When you are calculating, I'll come to that no, actually, let me mention it now. When you're doing maths, your teacher will either allow you to use a calculator if it's going to be messy numbers, or your teacher will allow you to leave it in surd form, which is just you say, okay, well, it's root 5 or whatever it is. So you just leave a whole number or an integer underneath the square root sign, and you're allowed to leave it as your answer without actually calculating what it is in decimals. But these are the Pythagorean triples. So the one we just did now was 3 and 4, and the hypotenuse would be 5. So multiples of this work too. So if I double 3, I get 6. Double 4, and I get 8. Double 5, I get 10. And so likewise, 9, 12, and 15 would work, and so on and so forth. But those are really just, I suppose, variations on the basic one, which is 3, 4, 5. This one is probably the only other one you'll come into contact quite often. It's 5. So 5 squared is 25. 12 squared is 144. 13 squared is 169. And if you're good at your mental arithmetic, 25 plus 144 is 169. So that would be your hypotenuse, and these would be your other two sides. And likewise, multiples of this also work. All right, jumping back to the whiteboard. Nope, jumping back to the whiteboard. That is what I messed up in my previous recording of this lesson. I thought we were on the whiteboard, but there I was on the whiteboard talking away, and all you could see was the slides. So I had to record that one again. All right, let's take a look at this triangle over here. Right, so I'm going to choose some different numbers quickly. Oh, wait, there is one thing I wanted to show you, and this is pretty cool. It's an animated GIF that's on Wikipedia showing you the diagram of how it works. So what they've got over here is they've taken the same rectangle and cut that corner off each of, I suppose, the corners of a square. So that length A is the same as that, is the same as that, is the same as that. And then C then would be the long one. So we've got A, B, and C. So that is the square that would be made by C. And then if you rearrange those four, you will have the square made by B and the square made by A. I'm going to watch that again. And again. And one more time. All right, that's pretty cool. You can find that on Wikipedia if you want. So just as a note, Wikipedia Commons is it means that these images are freely available to use and share and show. I'm quite careful about what images I use because most images online are copyrighted and I don't want to infringe on somebody else's rights. Okay, so we have another triangle. So I'm going to, with this one, I'm going to use numbers that are probably, in fact, no, let's go with a nice one for this one, and then I'm going to do the nice one but look for something else. So I'm going to say this is 5 centimeters, this is 12 centimeters, and I want to know what that one is. Now, if you were paying attention when we were a moment ago having a look at our Pythagorean triples, you'll already know what the answer is, but let's go through the process of working it out. So, and I think it's a really good idea. At this point in time, you should always start by writing down your formula. It's a good way of making sure it sticks in your mind. So a squared, in fact, you could even write it, because I'm looking for c squared, or c, you could say c squared equals a squared plus b squared. All I've done is put c on the left, but I haven't changed anything about what I'd written. Now I put my numbers in. C squared is equal to 5 centimeters squared plus 12 centimeters squared. C squared is equal to 25 plus 144, which is equal to 169. So c squared is equal to 169. And if I was looking for c squared, that would be useful. But I'm not looking for c squared, I'm looking for c. And because of that, I then have to take the square root of both sides, because what you do to the left, you do to the right. What you do to the right, you do to the left in an equation, because otherwise it's no longer equal. All right, so what is left on the left? What's left on the left? What spits out on the left is just a c, because the square root and the squares cancel each other out. And I ask myself, what times by itself is 169? And I happen to know because it comes up quite often. And the answer is 13. And so now I know that the length of that triangle that's missing there is 13. Right. Okay. So that's useful. That's quite nice and good. I'm going to take like those same numbers, but I'm going to say that's very nice. What if I wasn't given the long, or if I was given the long side and I didn't have to calculate that one, I had to calculate some of the other ones. Right, so what if I'd been given that one's 13 and that one's 5, and I want to know what that one is? But my formula says c squared. So what am I going to do? And I'll tell you what I'm going to do. I'm going to take a Nomu hot chocolate study break. Let's be honest, studying sucks. But here at Worksheet Cloud, we make it suck way less. In Worksheet Cloud, you can earn avatars, sidekicks, collectible coins, and then level up all while studying. Plus, we've just added our most exciting feature to date, the brand new Worksheet Cloud Rewards Hub. With Worksheet Cloud Rewards Hub, you can earn epic rewards and unlock entry tickets to win real giveaway prizes, including a Sony PlayStation 5, some yummy Nomu hot chocolate, and some fresh Worksheet Cloud merch. The more questions you answer, the more points you earn, and the more rewards you unlock. Worksheet Cloud makes your studying easier with video lessons, practice exams, practice questions, and study notes. In other words, we're your go-to place for all your studying. Ask your parents to sign you up at worksheetcloud.com today. All right, here's what we're going to do. Let's have a look at our formula again. We had c squared, I'm just going to write that at the front, equals a squared plus b squared. But if this was b, then I don't want to find out what c squared was. I want to know what a squared was. So this is where changing the subject of the formula comes in handy. Okay, so how can I do this? Let me do it on the right-hand side. Let's say I had 5 plus 13, 5 plus 12 equals box. And I asked you to figure that out. I think that you'd all be able to say that that was 17. But what if I didn't say that? What if I said 5 plus box equals 17? Would you then be able to figure out that it was, what did I have to do? I've got to add 12. I'm sure you would. Now, what you actually did was you said, how many more do I need to get to 17? In other words, what's 17 minus 5? So you said, okay, well, I've got a box on this side. What's 17 minus 5? That's 12. So my box must be 12. And you could have done the same thing with a 5. All right, so that's what's changing the subject of the formula is. It's an algebraic thing because we're looking for not what we had as the subject, in this case c of our formula, we're looking for something else. So what I'm going to do over here is I'm going to say, well, I want b squared to be on its own. Now, in order to get rid of this a squared, I'm going to subtract a squared. But remember what I keep singing, if you can call it that, what you do to the right, you do to the left. So if I'm going to subtract a squared from the right, I also have to subtract a squared from the left. Now, a squared minus a squared is just nothing. It's like 1 minus 1, 10 minus 10. A squared minus a squared is nothing. So I'm left with only b squared on the right. But on the left-hand side, my formula now says c squared minus a squared. And that, if you look at your triangle, means that the long side squared minus that side squared gives me that side squared, which makes a lot of sense. Now, if you want, if this is really not an area of strength for you, you can memorize the 3 different formulas because it's either going to be c squared equals a squared plus b squared, or it's going to be a squared equals c squared minus b squared, or it's going to be b squared equals c squared minus a squared. But the only thing that's really changed there is you've just shifted things around. So c minus a squared is what b squared is equal to. All right. I would suggest just be comfortable changing the formula. It's easier than trying to remember 3 things. Anyway, that was a very long-winded way to get to the fact that we are starting with c squared minus a squared equals b squared. So c squared was 13 squared minus 5 squared equals b squared. 169 minus 25 equals b squared. 144 equals b squared. Square root, b squared, b is equal to 12. All right, and that gives us the length of the side we were missing, 12, whatever units we were looking at. Okay, always like to do this, just change some of the way that you've displayed your triangles, just because we often just put them upright like this. Children get confused when we do it another way, but it works whichever way you are. So let's put in some that are not going to work out nicely. So I haven't calculated these. Let's make this 6 meters. Let's make this 4 meters. And let's see what we get. Okay, so let's say I want to calculate that. I'm going to go, well, this is the side I want. That's the long side. So c squared equals a squared plus b squared. C squared is equal to 6 squared plus 4 squared. C squared is equal to 36 plus 16. C squared is equal to 52. All right. Now, you can work out the square root of 52. It's not going to be a nice number. Let me tell you quickly by looking on my calculator. I could give you a roundabout figure, but that's not going to be good enough for you. I'm sure you're going to want the one. So 52, I've got to go this way to get a square root. No, pushing all the wrong buttons here. Quickly check my email. No, I'm kidding. So square root of 52. I don't even know how well you can see that. It equals 7,211 da 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 da. It's horrible. Let me quickly refresh my page. I seem to have lost connectivity for a moment. Right, it's not a pretty number. So your teachers will either allow you to work it out or work it out with a calculator, or they will allow you to leave it in surd form. And by that, I mean you can say then that C is equal to root 52. So you simply leave it as that. That would be your answer. So then you could say that the length of this side is root 52 centimeters. Okay. We're going to do one more straightforward one. Then we're going to look at some complicated ones. Not really, but how it might be used in situations in maths. And I'll mention a couple of examples how I use it in real life. And then you're going to practice this yourself. Okay, so moving a little bit down so we can see that. No, I don't want to see my complicated ones yet. Just looking at this one here. Put my right angle triangle there. All right, so this time I'm going to say that this is 10 meters. This one is 8 meters. And I'm going to ask, what is that one? All right, well, again, we now need to change the subject of the formula because we have the long side, which is called the hypotenuse. All right, so what we've got then is c squared. Well, let's choose it. We'll make this one a. So a squared is what we're looking for, is c squared minus b squared. So a squared equals 10 squared minus 8 squared. A squared is equal to 100 minus 64. A squared is equal to 36. I don't want a squared, I want a. So I'm going to take the root of both sides because it's stuck in your head now, isn't it? What you do to the left, you do to the right. I just realized I might be saying that, and because you're looking at an image of me, it might be the other way around. I'm not sure. I always get confused with cameras and mirrors and how they turn us. But whatever you do to one side, you've got to do to the other. Otherwise, it's not equal anymore. All right, so we've got a on this side and the root of 36. So what multiplied by itself gives us 36 is 6. So our answer then for that length of that side is 6 centimeters. It is a Pythagorean triple. It is a double of 3, 4, 5. It's 6, 8, and 10. All right. So again, you might get something like this if you're working out irregular shapes and you have to work out the perimeter of this one. So for example, they might say that this one is 4 centimeters. This is 2 centimeters. This is 2 centimeters, 2 centimeters. And then they might say to you, this is 2 centimeters, and this is 2 centimeters, and they want you to work out the perimeter. Now you have enough information to do that. We have certain sides that we've given or we've got already. We've got this one, this one, this one, this one. We need to work out this one, and this one. Right, these two will be the same. So let's actually just work that out once. and then the longer one will be also something different. All right, so let's start with the two that are going to be the same. These ones down near the bottom. All right, so we are looking at, this is our right angled triangle. So you've got c squared, that's the side we're looking for, is equal to a squared plus b squared. So that's 2 squared plus 2 squared, 4 plus 4. So then c is the c squared is equal to 8, and c is equal to the root of 8, which isn't a nice number. But, oh, I'm off the bottom of the screen. But you'd be able to punch it into a calculator. So you'd know that those two lengths you now have. And likewise, we need to find this length. There's our right angled triangle. We need to find this length. Right, and to do that, we will then say, we're looking for the long side. So c squared is equal to a squared plus b squared. C squared is equal to 2 squared plus 4 squared. C squared is equal to 4 plus 16. C squared is equal to 20. C is equal to root 20. Now that last step, what I did a root, and I did a root, and then I ended up there. Once you're comfortable with it, I did it on the other one as well. You won't have to write down the root. Now for this, your teachers would allow you a calculator. All right, the last one, just because this does get complicated, I'm going to show you. If you had a situation like this, I'm not going to work it out. Maybe I should. Yeah, why not? So let's say your teacher gave you this pyramid and said they want you to work out the height of the pyramid. Now, this is not something you can do in a single step. This is a couple of steps together. So the first thing I'm going to do, I think this is why I get a little bit excited about this, but the first thing I'm going to do is I'm going to work out this length there. And I'm going to do that because I know those two lengths. So that then would be the c for that triangle that's half of the base. Once I've got that c that's half of the base, I'm then going to look at the triangle that is formed with the edge of the pyramid and the vertical height and this. Now I know my diagonal will be broken in half exactly, so I can take half of the length of that, and then I can multiply. I can take the square of this and subtract that, the square of that, and then I can get what the height of my pyramid is. Very roundabout, but there you go, you can do it. All right, so I'm going to go, well, first of all, calculating my green, so that's the diagonal of the rectangle that makes up the base. So c squared equals a squared plus b squared. C squared equals 3 squared plus 4 squared. C squared equals 9 plus 16. C squared equals 25. Root c equals 5. So I've worked out that that length in total is 5. Now the height of the pyramid would be at exact midpoint of that. So that means that the short length there would be 2.5 centimeters. All right. So knowing that, I can now shift over so I've got a little space to work over here. I'm now looking at the purple triangle. So I know the long side, I know c squared, that's 6, and I know the short side, which is 2.5 centimeters. So I'm looking, for example, at that one. We can call it b. So b squared is equal to c squared minus a squared. B squared equals 6 squared minus 2.5 squared. All right, so b squared equals 36 minus 2.5 times 2.5 is 6,25. So, squared b squared is equal to 29,75. And b is equal to, because we root both of those, is the root of 29,75. All right, so that then would be the height of your pyramid. I know it's very nerdy to find that exciting, but I do. So Pythagoras, as I mentioned before, is one of those ones that I have come across and do use actually in, oops, let me just get you over to the slides again, in a few different places in my life. So where have I used it? Okay, so for example, I was putting up a post in the garden to support something, and I needed to know the length of a piece of wood I should cut that would go between the ground and the post. And I knew how far away the piece would join and how high up the post I wanted. So I used Pythagoras to find out how long the diagonal was I needed to cut. I was putting up a shelf the other day to put plants on. And I needed to, so if the wall is over here and the shelf is over here, I needed to put a support between the end of the shelf and the wall. And again, that forms a triangle, and I can use Pythagoras to do that. Just a couple of examples. I do use it quite a lot. I enjoy my DIY, but it's one of the ones I use more often. As I always say, you don't learn maths by watching, you learn by doing. So click on the link below the video in the description, download that free worksheet from Worksheet Cloud, and get practicing so that it goes into your head and you feel comfortable using it when your teacher's doing it in class. Finally, if your parents have not yet signed you up for Worksheet Cloud, send them over to worksheetcloud.com to sign you up. Get you access to all these cool lessons and worksheets so that you can practice and do well at school, but also it gets you access to that rewards hub where you can earn those cool rewards like the Nomu hot chocolate to sweeten the study breaks, and possibly even that PlayStation 5 for after you do so well in your exam. I hope to see you soon, grade 8s. Cheers.